All right, we are going to learn about exponential functions. But before we do, we got to do some review on percents. So let's talk about percents. A percent is just a number out of 100. So when I talk about something like 17%, what I'm really saying is that it's 17 over 100, which as a decimal is 0.17. And the reason I'm reminding you about that is as we start to write some equation, that decimal number is the thing that's most important. So let's talk about writing equations. Now, we've done linear equations before. We're sick of those. Y equals mx plus b. M is our slope, that constant number that changes. B is the y-intercept. It's where it starts. Today we're looking at exponential equations. Same letters, but kind of different how they're used. So I wish that they weren't like this, but some other math person decided that we were going to reuse A's and B's. So A, that number in blue, is where it starts, the number in front of the parenthesis. The B number is going to be our rate, the percent. So for example, we could be growing or decaying. These problems we're going to look at a lot of times are going to have to do with money. So you're getting a percent amount of money every month, or maybe you're losing some money every month. So what we'd end up with inside the parenthesis would be for a growth function, 1 plus the decimal, or if it's a decay, 1 minus the decimal. So maybe 1 plus 0.17 or 1 minus 0.17. And the 1 represents 100. So now that we've talked about the basics, let's actually try a problem and see what it looks like. Okay, so here's our problem that we have right here. A new car is purchased for $20,700. The value of the car depreciates at 11% each year. What will the value of the car be in 5 years? So this is a real absolute problem that happens in the real world all the time. You buy a new car. 5 years from now, you still have that car. There's no way you could resell that car for $20,000. It goes down in value every year by a percent based on how nice the car is, right? So what we're going to do is we're going to write an equation, and then we're going to plug in 5 and find out what it'll be in 5 years. So the two important things that we need to know, 20,700 is our A value. It's what we're starting at. Okay? Now, in this case, my B value, my rate, has to do with the 11% and that I'm decreasing. So because this is decreasing, depreciate means it goes down, we call this a decay function. And it's going to be 1 minus this as a percent, which would be 0.11. And remember, if you didn't remember how I got that, 11% is the same thing as 11 over 100, which is the same thing as 0.11. Okay, so 1 minus 0.11 would be 0.89. Okay, I just subtracted there. So now I'm going to put this into my equation. So I would have y equals 20,700, you don't need the comma when you're writing it in your equation, times 0.89 raised to the x. Exponentials have an exponent, that's why they're exponentials. Now this equation would work for any year, 10 years from now, 20 years from now, 100 years from now. I don't know if you'd really still have that car 100 years from now, but I could plug it in for any one of these. This problem asks for 5 years, so I'm going to do 20,700 times 0.89 raised to the 5th power. And there's no way I can do that in my head. So I'm going to my calculator and I'm typing it in exactly as I wrote it. And what I get is $11,559, and according to my calculator, 0.00 cents. So I don't have to worry about any change. So I bought a car for $20,000, and then 5 years from now, I could sell it back for $11,559. All right, so now we're going to do one more exponential problem, and it's going to be a growth function. But it's still exponential because I'm dealing with the percent. A town has a population of 17,000 and grows 4% each year. What will the population be in 6 years? So I'm not adding 4. I'm not doing 17,000 plus 4 people this year. I'm doing 4%. So that's why I know it's exponential and not linear. So I know that my starting value, A, is 17,000. I have 17,000 people in this town. My rate has to do with this 4%. So let's remember how I write that as a decimal. 4% is the same thing as 4 over 100. And 4 over 100 is 0.04. So just be careful that you notice that it's not 0.4, it's 0.04. So my rate, this is going to be a growth problem. So I'm going to do my 1, which represents 100, like a percent, plus 0.04. So when I add that together, my rate is going to be 1.04. And now I put it both together to make my equation. So y equals 17,000 times 1.04 raised to the x. And remember, x is exponential. It's up at the top. This problem wants to know what will it be in 6 years. So I take my equation and I plug in 6 for my exponent. I go to my calculator because I cannot do that in my head. And I will get, I will get 21,510. Now, I do have a decimal here, so if you did this on your calculator, have a decimal, but we're talking about people. I can't have a decimal of a people. You either are a people or you are not a people. So I rounded this up to a whole number, and so in 6 years, my population will be 21,510.